Okie doke. Let's go. So last time we talked about sorting. How far did we even get? Not very far, huh? It's taking an array from one state to another state, which allows us to traverse it more efficiently. Not traverse because that's just moving along it, but it reduces how much traversing is needed because if I can sort it alphabetically and I look for the person with the earliest name, oh, guess what? He's going to be the first guy in the entire array, or the last for the last letter. Or if numbers are ordered in a particular way, oh, maybe the small is at the start or the end. Oh, well, if we're searching for this, it does it this. If we're searching for this, it does this instead. So, you could have a function, an algorithm, I guess, right? An algorithm that says, oh, what are we searching for? Oh, we're searching for it like this? Okay. And it does this to the array. Oh, we're searching for it like this? We're going to do this instead. That way, it's not dynamically adapting, but it is responding most effectively to the way we want to search the array. And then that might depend on how the array is sorted. Because if it's sorted, maybe we have to traverse the whole thing. If it's not sorted, we have to traverse the whole thing. If it's sorted, we only have to do this. If we know that the array is sorted this way, then our algorithm needs to do this type of search. If we're doing this one, we have to do this type of search. So I think, what do they call it? Do they call it selection search? Not selection sorting. I think it is selection sort. The one where, for a number, for example, we know that it's like this. We're going to search for 75. Start in the middle. And we know that it's from least to greatest. Oh, okay. We're in the middle. We're too low. Okay, so we go half high. Oh, too high. Too low. Too high. Too low. Found it. Boom. We can go really quickly from it. Like, if we're searching for... Then, right? Alright, oh, I'm searching for 9. Okay, so we go right in the middle. 6. Too low. 9. Done. If we're searching for 7. Start in the middle. 6. I guess maybe it checks each time it checks the ones next door. I'm not sure. But we could half. Too low. Too high. Too low, or maybe it's too high. And then it goes, so it gets it within a couple. Okay. And you could pretty quickly whittle it down. Okay. I was wondering what I needed. It's not my headset, it's the glasses. Okay. We could repeatedly compare different array or pairs of array elements and swap them if they meet the criteria. Because the main one I'm thinking of is bubble sort, but what's the strat here? I guess you could find the lowest one and then swap it with the first, and then find the second lowest, and then or find the lowest again, except the first, and then swap it with the second. It's like you could subtract from the array after sorting, so you don't have to check the same element, because otherwise it'll be the smallest every time. Bubble sort seems like it makes the most sense here, or it best meets this definition. Excuse me. Makes sense. Yeah, that makes sense. Yeah, because if we're gonna swap them, if left is greater than right, then it means we want it so that right is greater than left. We want it from least to greatest. But if we're gonna swap it if left is less than right, then we're swapping it so we want least on the left. So we're going greatest to least. Descending order. Could do standard swap. Yeah, I was hoping that he said can use and not we use. That's true, because it's easy enough to implement. Certain utility, we just swap. Boom. Yeah, because how this is actually implemented is we just have a function template, and then we define it with I guess you could go either way, but ideally, if we're talking an array has to have elements of all elements of the same type, or the same type for each element. So maybe we want to say, oh hey, it can only accept 2 of the same type element, and then we just compare them however we want, and then we swap. Or we do the comparison in this function, and then we call the swap. So we say, oh hey, is this less than this? When we swap. Or in this case, it's just showing what happens and then showing that you swap. You're basically passing 2 L values by reference, and then you're assigning one's value to a temporary variable, and then you're assigning the other to the first one, so you've now swapped 1, and then you take the temporary value and then put it on the second one, or vice versa, and then boom, you've now swapped them. Temporary gets deleted. You've assigned them and updated them via reference, or you've updated references, which means you've updated the actual places in memory, so the values have been changed when you return back to the main function, or whatever you're back to the caller. To clean the front of the PC a little. So before swap, we have 2 and 4 probably. Yep. And then we swap. After swap, 4 and 2. Yep, cool. 4 and 2, yep. Here it is, selection sort. Okay. Actually, oh, there is selection sort. Interesting. Oh, selection sort is you go through the entire thing and you select one. Oh. That's the hard part. Oh yeah, because this is selection sort is the one that you listen to, where you take the array and, or I guess kind of. Yeah, because it's like, well, I guess the point is it's found the smallest one, replace, found the second smallest, replace, and it keeps going, and then boom, it's in order. Yep. Oh, because it's comparing to this guy, which is the smallest, and then it's finally found the next. Replaces. Yep. Makes sense that it sounds chaotic. So many comparisons. Oh my god. Going through the entire array every time. And for every element you add, oh my god, for every element you add, it's another comparison. It's probably an extremely inefficient way of doing it, right? I'm surprised it speeds up so fast here. I don't know how it's able to... I guess it's just the sounds. It is maybe this... Well... Is the point that it's able to traverse it that much faster? Sound at the end is hilarious. I kind of just wanted it for that. Yeah, it's one of the slower sorts. Oof, I don't know what would be slower, really. Search the entire one, swap the smallest with the first, and then find the next, and then swap it with the next, and then boom, every single time. Oof. And I guess the point is that we say the index of the search is the index we're going to replace. So you could make selection sort by you pass in an array in for int I starting to be 0 while it's less than the standard size. So you go through the whole array, standard size or S size, let's say standard S size of the whole thing. But really it's S size static casted to be an int if we're talking int. Or we could just make int be a standard pointer diff t. So for each element in the whole thing, we search the array. So I don't know how the search happens. I'll just say find. In the array we search, or rather we say, actually no, we, I guess that'll be the search, huh? We have enough, so for each element in the array, we have the smallest, we have this value called least, and we assign that element to be, hold on. Right, because don't we need the loop for each time? So we need to do it one search for each element of the array. So one whole search to find this guy, and then we assign. So loop for each element in the array, integer least, for each element in the array, if the value is, or well, first, how do we do this? We want to assign the first element, but not the rest. So let's see. Oh, gotcha. Gotcha. Okay. So for each element in the entire array, search from whatever index we're currently looping for, from there to the end, and assign that value. Check each time that index for the second loop, the inner loop. Check if that index is less than, or well, really it should be a Boolean is first element true. Oh, well, hold on. I'll implement this in a sec. So this is how we go. Okay, all right. I'll do selection sort in a sec. So in the second loop, no, so that's what happens. So in the second loop that starts at a particular element, let's say we've gone a couple times, we're on the third element now. So we set the third element's value to be some object before we loop, and then we loop from that element on. So we're comparing that value to the next, and then continually comparing to the lowest. Oh, we found a lower one. Okay, now that one's set. Comparing. Oh, we found a lower one. Comparing. That's the final one. And then at the end of this loop, we then assign that value to be the next element. Excuse me. We assign it to be, to be the element we're looking at. So if we're on index 3, okay, we're on 3 now. Or we've assigned that value to index 3. And then we go to the index increments, and now we're on 4. We save the value of index 4, and we search from 4 on to get the lowest value, and then we assign that to be 4. So we're going through, finding the lowest value, putting it here, starting the next one, searching the whole array, finding the lowest element, setting it to the second element, searching from the third on, finding the next one, assigning it to be the third, and then on. That's how we do it. Okay. Do it. Selection sort. We're gonna need to swap. We'll do swap, and then we'll pass in those 2 indices, right? Okay. Selection sort. Okie dokie. So what do we want? We want a swap function. We want a standard array, so we'll include array. Excuse me. Okay. All right, we also want to be able to output it, so we put it in global, I think. So an inline standard output stream reference, and then operator insertion, standard output stream reference output, and then what do we want? We want to output a standard array. Well, yeah, right. So we do a standard array of some type, and then a size of some type, int size. Standard array of t and size. Call it array. Good so far? This is gonna have to be changed. Oh, it's cool. Okay. And so we'll loop through the array, right? And then print it. Okay. Okie doke. And then return output. Okie dokie. Alright, so that's how we print an array now. Make it inline so we can define it elsewhere. Okay. So we'll do a function called swap. Alright, I think that's all we need. So we'll do swap, and then we'll have a t a and a tb. Oh, sorry, and it's a t reference. Not a const reference because we're changing them. And we'll do, that's it. So we'll do a t temp, and we'll initialize it to be b, and we'll say, or I guess we'll do a, and we'll do a is now b, b is now temp. Okay. Okie doke. So what if we said selection sort swap x indexed with 0 and x indexed with 2. Oh shit, okay. Pre-swap. Oh, we also have to print it, right? Oh, and then x, and then post-swap. So first we have 1, 2, and 3, but then we swap index 0 the first and index 2 the last. 3, 2, 1 now. Okay. Cool. Works. Swap two objects. Values. Sure. And then what else do we want? We want, if we did sort, or I don't think I can add it to standard array class. Is there a .sort? I'm curious. Oh. Okay. Selection sort, and it takes a standard array of something. And we could, it's fine, it's not complex. Type name t, and then int size, right? And we'll say we take a standard array of some type t with some amount of elements, and it's called array. What are we doing to the array? We're sorting it. So we need to, for each array element, find the lowest selection sort, least, greatest. Least to greatest, okay. Find the lowest value and assign it to, well, hold on, and swap it with the current element. Or follow this value with the current index. Then increment the index. After, well, yeah, and that's it, right? So for each element, so I think we have to start with index of 0, right? And then we need algorithm for standard size. Algorithm is before. For, we'll say, and do we want pointer diff t? Sure, why not, right? Standard pointer diff t. Index, or oh, what the hell? I did end. Standard pointer diff t index. And while index is less than standard s size, so we need s size to get the signed size of array. Excuse me again. Increment index. Cool. Oh, I totally did that. I'm just gonna do I. Why not? Okay. And then nested, we're gonna do, we need to start from I onward, right? We can't do a for each because the for each gets the entire array. So for again, for a standard pointer diff t, j, sure, j is less than standard s size array, increment j. And maybe we say j starts with I. So if we're on the 10th element, we've sorted the first, we want to start from the 10th onward. I think we initialize j to bi. Okay. And so I think we have to also nest this because we need something here. We're going to say we have a t something. So we're going to say a t lowest. And it's going to be right? Yeah. Initialize with array I. And so we'll get this element, and we're going to assign values to it if it's the lowest. And then at the end, let's see, hold. And at the end, we say array I is now lowest. Or we could say if and not assign it. We could check it each time. So sure, why not? If array I well, how do we handle the equals, huh? Well, I guess if we start at the next one, that would be the lowest then, right? I think it would work. I think it still works. Right? Let me think this through and not just go through muscle memory and force it. So if there are two 5s, and we've gone up to 4, and 5 is the lowest now, and we start at whatever, let's say we have like 7, 6, and 2. 7, 6, and 8. We go 7, 6, 8. 5 is the lowest. Boom, and we go through, and 5 is the lowest. And then we go through again. And even though 5 would be the lowest again, and 5s would be next to each other. So it should still work. So And we say if this current element that we're looping on is greater than lowest, then array I, it's not swap, it is swap array I and lowest. If array I isn't the lowest element from this loop, swap it with lowest. Swap it with lowest. Okay. Track lowest element from right I till the end. Till end. Okay. Find lowest element. Okay. And so we'll say if array j is less than and really we could start at this could be I plus 1, but I think we start at I'll start at this because once we get to the final I don't think we want to increment by 1 because then I'm gonna go 1 too high I think. So we'll do if array j is less than lowest then gets array j's value. If this element is the lowest so far, store it. Save it as lowest. Okay? And then at the end, after the search, if array I isn't the lowest element, swap it with the lowest. And actually, it's not swap lowest, it's lowest should be the index of the lowest, actually. So lowest should actually be a standard pointer diff t. Pointer diff t lowest index, and it's indexed with I. And lowest should actually just be getting the value of j. Okay, I was wondering, I'm not seeing any red. What's happening here? Okay. Okay, so we're getting the lowest index, and this is not swapping it with that, because this is a pointer diff t, this is an array indexed, so this is an int with a pointer diff t. No. This is array getting the lowest index, and this is array getting lowest index, and again, if it's less than the lowest index, or hold, yeah. If this array is less than the lowest index, the lowest index needs to then be j, right? Okay, so we'll do 1 and 2, fuck it. And then we'll do, all right, let's build. Uh-oh, why? What happened? 45? What are you bitching about? Oh, Wait, what? Bro, what are you saying? Well, I don't want this to be defined. Hold on. If I include this in one header file or in one file, I think these need to be inline, right? Well, selection sorts being forward declared. Oh, I need to fucking put these in the implementation file. What am I doing? Okay. So I'm pretty sure. Hold. Actually, I think, does the template need to be defined? I think it does. Maybe not. Hold. Let me find this error first. Hold on. And I'm not going to include this real quick. Excuse me, at line 44 and 45. Hold. Oh. What the fuck? I put that, but then I didn't put array because I'm stupid. Whoops. So what if we include all this, but then we don't need to include any of this? Oh, I didn't mean to fucking do everything. Jesus. And I'm pretty sure this has to be defined in every unit, but maybe not. Let's see. And then here we've got swap. Oh, okay. Guess it's okay. So here we're forward declaring this guy. Okay. Now what if we do selection sort X? Hold. What does it take? It's a standard array of something and a something. Do we explicitly need to specify? Oh, wait. Oops. The fuck? Forgot the name of the damn function. Hold. Selection sort least greatest and maybe they do need to be defined actually. Oh, oops. What? Selection sort H. 45. Did I... Hello? Hold. Lowest index needs to be that. These are the same. Hold, what are you saying? If array indexed with J is less than array indexed with lowest index, why is it pissing? Even still? Oh, why did I do int? Because then if I'm defining it with a specific type, we're going to get conversion issues there, right? Excuse me. Excuse me again. Excuse me again. Fuck. Point of t. I mean, we could static cast it, right? I mean, I don't want to do a size t. We're not decrementing, so size t isn't bad here. Why not? Fuck, I wish I could just place that. It's so annoying. Less than signed unsigned mismatch. Hold, what are you saying? 36? Oh, here we go. Now we have to do size and size. Let's get rid of those. Okay. Alright, pre-sort, post-sort. Oh, good. We didn't pass it by reference. I am a dummy. Sorting an array that doesn't exist. Rather, it does, but it's just copied. Okay, even better. Swap, taking by reference. So if I'm passing this guy by reference, what is happening here? Okay, so in our case, we start at 0. And we go while we're less than 2, so for 0 and 1, it'll do this. Okay. We get lowest index is 0. And then from 0 to less than, while j is less than, well, while 0 is less than 2, so 0 and 1. We check is 0, so we start at 0. Is it less than array of whatever the lowest is? No? Okay. And then we say the lowest index is j. Oh, because we're already sorting like that. We're not, what the fuck? So 2, 1. It's already working. I just had it stupid. Okay, here we go. Okay, how many 8s do we have? 1. How many 8s? The last one. How many 6s? 1, 2, 3. 3 6s. 3 4s and 2 5s. 5, 5, 4, 4, 4. Okay. Okay, yeah, it looks like selection sort works. What if we did standard array of characters? It could be, yeah. Or D-E-A-Z-A-I, but now it's A-A-D-E-Z, or I-Z. A-A-D-E-I-Z. Cool, works. Selection sort is cool. Was there a way I could have improved this? There might have been. Yes, there's one. I like const expression to be after. And same here. Or, yeah. And then this is printing, so no, not there. Cool. QQ. Don't need this guy. Oops. Because everything we have involves templates. Okay, so that's selection sort. How far are we? 47? Okay. Alright, so many ways to sort an array. Selection is the easiest to understand. Oh, great! Starting at 0, search the whole thing, swap the smallest value found in the array with the value found at index 0, and repeat with the next index. Find the smallest, swap to the first, find the second, find the next, smallest, swap to the second, find the next, swap to the third, etc. So 30, 50, 10, 20, 10, 40, 10, 20, 30, 40, 50. So, okay, what is the smallest element? 10. Swap it. So now it is 10 and then 30 is there. And then we're going to find 20. Swap it with 50. Okay? And then we're going to find 30. 30. Swap it with, well, 30 will have been swapped with 10. So find 30. Swap it with 50 maybe. Hold. Okay. Swap 10 and 30. Look through, find 20. Swap 20 and 50. Or hold. Yes, 20. Jesus Christ, he's taking it so long. Swap 20 and 50. Yes. And then swap 30 and 50. Okay, exactly. And then swap 40 and 50. Boom. Find 40. Swap with 50. And then find the smallest. Oh, it's 50. Oh, 50 is not less than that, so leave it alone. Cool. Done. Yep. So we can actually stop. Yeah, that makes sense. True. Right? Because if we're swapping, we don't even need to do that for the full array in the beginning. So we could actually do it with -1 for both. Ow. That's pretty easy. Oh, I did it in the same thing. Okay, so he did it specifically for an array, a C-style array. So he had a C-style array, the length. What the fuck? What the fuck is he doing? Getting int. Oh, a length is an int. Static casting from the size. Yeah, true. We could do that. Then I was gonna. I don't know why I did pointer diff instead. And then yeah, for 0 to the end -1. Because we're doing swappy. So the last one only happened after all the others before it had been sorted. And if all the other ones had been sorted before it, it would probably have been moved around. And then, boom. I guess it would never be swapped on. Or no, because whatever is the lowest at the end would be found at some point and swapped to where it needs to be. And that might happen a bunch of times, but the point is by the time we get to the last one, it's already there. Smallest index is the index of the smallest element. Hold, what? Smallest yeah, that's what I had. I just had lowest index, but you could do either way. Because I said least lowest instead of smallest. Yep, so we do that, and then we loop through. In this case, he's doing start index plus 1. Yeah, you could. That's why. Okay. Oh, that's the point. I forget that you can start, and for some reason my mind was being stupid and connected. Oh, if we start one later, we're gonna end up one later. No, bro, you just start one later, stop at the same time. And when we do this search, we do have to go to the end because we don't know. We could be skipping the end. Hey, did it the same way. Yep, and then I passed these two via reference. Specifically, it's receiving 2 integers by reference, wherever the hell they are in memory. It doesn't care that they are elements in an array. They just swaps the integers in memory. Bop. Then we can loop through the whole thing and print it. Now it's sorted. Print it. No, that's fine. Slowly getting better with them like that. So loop iterates through each element one by one. For each adder, we look through the whole thing. Yep. Our loop advances one element. The process is repeated. And if you're having trouble figuring out, what is this, quicksort or something? Got some seed action going on. If you're having trouble figuring out how the program works, it can be helpful to simple case paper. Starting ones, smallest manually trace. Yeah, true. Break it down if you need. Okay, makes sense. I'll think about that when I get stuck again. Sorting names works using the same algorithm. Yeah, makes sense because we just changed. Oh, well, true. Yeah, because the first thing would determine it. Makes sense. Oh, because it's like a different number in the beginning. So if we assign, I guess we do, right? Well, let's see. I guess when you evaluate strings, you're evaluating the first character, huh? So that when you sort Ethan and Jake, E's before J, so E is lower, so E comes first in this case. Let's take a look at something cursed real quick. Oh, bro, why is it on my screen? Oh, what? It's just a dude's face. That's all it is. It's just a guy. It's his face. It's this guy here. And so is that. Man. I'll do 10 sissy squats and 10 good pace push-ups. Maybe 15, we'll see. Need to stay even further back. At least going up. Excuse me. Whew. Excuse me. 3 more. Okay, be right back. Wash my hands. The only sort I can think of that's less efficient than selection sort is like bidirectional. Excuse me, holy cow. My diet recently has been a little fucked up. Been burning the butter a little too much in my chicken. Had to throw it out today for lunch. Maybe it's a cinnamon roll I finished. I don't know. Little splurge, $4. Would be instead of having a for each loop or a for loop that goes bum 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 bum, you then go bum and track that index, and then go to the end, track that index, go 1 plus this one, 1 minus this one, bum 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 bum. Just because you're tracking it in a different way. And maybe that's less efficient than just doing, well, it's definitely less efficient than just looping. But you're looping, but you're also doing it with extra shit. It's like the only one that's worse, right? Because for every new element, boom, that's how many times the sort will take. It always takes however big the size is minus 1. Yeah, like to sort an array that's size 4, granted the loops are smaller, sure, but if it's like 4, 2, 1, 3. We have to find 4, 2, 1. Boom. 1, 4, 2. Boom. 4, 3. Boom. 4. Boom. So let's find the lowest. Find the lowest. Find the lowest. Done. Sort lives in algorithm. That sort? How does it sort though? Least to greatest automatically? Oh. We pass it some interesting stuff. We pass it the iterator? We know we need algorithm. Please. Excuse me. Oh, it is. First and last, and brand, it is the iterator? Oh. Excuse me. And returns a standard array's iterator. So it returns the iterator of a standard array. So standard array has a type defined inside it something like, or like, so type name T, then, right? And it's array, standard size T. What am I doing? Array of T size. Here it comes. Whoa, hold. Oh, excuse me, I guess that's true. It has a C style array of something, so it's a T array or data maybe. And then it's what, a reference wrapper and getting a reference to that. I think that might be what that is. So the point here is there's some sort of like iterator definition. Boom, and somehow that's defined as begin. Or rather, really what's happening is somehow an iterator is like a piece of a class. It's like something that maybe lets you step through it that's used when we're looping. Seems like what's the point of an iterator? To iterate, to complete some task and then evaluate and complete again. And what's the task? Probably getting that element and then going to the next index if possible, and then repeating. And then we have some, and I guess it's like, what do we even say it's returning? An iterator? I guess so. Because it's returning an iterator of this. So it's like this iterator or something, and it's called begin. And then it comments maybe return something wherever the iterator is. I'm not sure. It has to be defined inside somehow. And then we'll do for const auto reference element in IDs. Hello, I need standard character output. One to 5, so it's 152. Sort is 1 to 5. Oh, can I see how it does it? No, not like that. Fuck. I cannot. Unluck. Sorting arrays is so common. Bubble sort? Bubble sort. Hold. Sorts in ascending order using operator less than. Is this guy less than this guy? Swap. Wait, isn't this just bubble sort? Well, it could be either way. It could be setting it to be the first one and then comparing less to find it. But it sounds like here we're comparing pairs of elements and swapping them if necessary. This sounds like bubble sort. Manually show. What does that even mean? Manually show how the sort works on the following array? I mean, we're going to see like inheritance hierarchy, so I guess we're going to start drawing shit. Manually show how it works on this array. 30, 60, 20, 50, 40, 10. 30, 60, 20, 40. Fuck, where's 50? 20, 50, 40, 10. Did it for the 10. 3, 2, 6, 5, 4, 1. 3, 6, 2, 5, 4, 1. Okay. So we'll do green for the find, or red for the find target, and then swap. Find the least, found, swap. Well, fuck the colors. 10, well, 10, 60, 20, 50, 40, 30. Find the least. So it's not him, excuse me, and this is the marker at first. So this is who we were looking at first. This is who we're looking at next. Found, swap, 10, 20, 60, 50, 40, 30. Forgot the 0. Looking at him. Found, swap, 10, 20, 30, 40. Wait, oops. 30, 50. It's so slow, dude. It's so fucking slow. 60. Looking at him. Found, swap, 10, 20, 30, 40, 50, 60. Looking at him. Alright, well, looking at him. Not less than. And that's it, because we end less than 1. So we're not checking anymore. Done. Oh, or I mean, yeah, you could show it. So you could say, let's see if I can even say it out loud. Probably not. 30, 60, 20, 50, 40, 10. Okay. So we found 10. So now it's 10, 60, 20, 50, 40, 30. Okay. Now I find 20. So now it's 10, 20. Fuck. Blah, blah, blah. Whatever. You know how it is. 10 found. Swap. 20 found. Swap. 30 found. Swap. 40 found. Swap. 50 found. Or, well, in this case. So we're looking here. So this is the swap. Looking at 50. Oh, I didn't do a self swap. I said, hey, if it's not less than, don't do it. And then we're done. And in his case, it wouldn't even look here because he said it goes through less than 1. So that's a mistake. Because the second one loops through all of them, but his first one doesn't check this one. So it wouldn't check. Rewrite the selection to sort in descending order. What? What are you talking about? Isn't it the same? Hello? What is it? Okay, bro. There's no point in doing 3, 6, 2, 4, 5, 1. That's what I'm doing regardless. 5, 4, 1. Okay, who cares? Okay. Find, looking here. Find the biggest. Swap. Looking, or well, looking here. Find the biggest. Or actually, hold. Wait, no, because 6 is greater. What the fuck am I doing? Find the biggest. Swap. 6, 3, 2, 4, 5, 1. Find the biggest. Looking here. Swap. 6, 5, 2, 4, 3, 1. Looking here. Find the biggest. You. 6, 5, 4. Alright, who is swapped? You. 2, 3, 1. Looking here. Find the biggest. 3, 6. Swap. 6, 5, 4, 3, 2, 1. Looking here. Find the biggest. Not less than. No swap. 6, 5, 4, 3, 2, 1. Not looking here. Done. Or in my case, I didn't do that. Looking here. loops one time, not less than, no swap. Oh, and if we're rewriting the code, if we're saying that, then sure, it's easy enough. Need standard sort. Excuse me. Excuse me. Okay, so we're gonna do standard array, array. Okay. And then we'll say, oh, well, I mean, one of them to rewrite the code. Wait, what? Hold. Oh, shit. Rewrite the okay, I'm just stupid. I didn't rewrite. Rewrite the selection code up here. Sort in order. This is the print part. Oh. Wait, is that how it works? Nah, there's no way. Really? Excuse me. Fuck. Never mind. I was hoping. Okay, so we can't do that. Oh, wait, is it to sort it or to print it? No, it is sorting. This is simply printing and this is simply sorting. Guess I'm real dumb. Rewrite the code to sort in descending order? I mean, right now we're literally just using sort. Oh, is there a way to flip it? Fuck. What is it? Is there a way to reverse it? It's gotta be you sort it and you just add something, right? Begin data empty fill front. Do we just loop through and swap? Oh wait, hold on. We've sorted it. Pretty sure I have to track both sides. Oh, wait. It is the last, because if we swap this one with the last... Hold. If it's sorted 1 and 9, and we swap 1 with 9... No, we can't then just fucking swap 2 with 9. Bro, what am I thinking? It has to be 1 with 9 and 2 with 8 to get 9, 8. Okay. Oh, what? I am not seeing this. All this is doing is printing the array. This is sorting the array. We can't pass in the reverse of the array. I mean, I don't know if there's any built-in thing. So do I have to just write the selection sort, right? No, and it's saying that this is selection sort, so don't I just have to write selection sort? What does he want you to do? Wait, he is saying that. Oh, bro. This isn't the selection sort code. This is the selection sort code. Oh my fucking god. Selection sort, Ethan. Selection sort. This is fucking bubble sort and standard sort. This is different. Okay, alright, let me write it then. I'm being dumb. Oh, I mean, I don't, like, this is just gonna be a regular thing. I'm feeling, I don't know, lazy. I feel like I shouldn't turn off the music. I don't know, I wanna see this. I'll watch the. That's fine. Okay. Alright, I want this music real fast. Sure, I'll do it in main. I don't want to, but I will. We won't even do that. I don't know if I even need that. Sure. I guess it was easier in his case. He didn't even need to do the templates or anything. Well. Excuse me. Okay, how do we want to do it? I mean, if we swap them all, I think we can ignore the last one. Yeah, right? If we sort all of these, eventually everything will be in order except one, so they can't be swapped. There's nothing else to swap, right? So I think I need the integers here too, yeah. So we'll do greatest index. And we start it with I. I mean, fine. Okay, so we start one element after I, J, and we go to the end and we search the whole thing. So if array J is less than array at this current index, or oops, then set greatest index, or hold on, if the value we found okay. Right? Let's see. So for each element in the entire array, set this guy 0 to be the index, and then we start from here through the end. Start here, and we check. Is this value, is the array at this element greater than the array at wherever we started? Well, we're at this, well actually, hold on, starting, sorry. Yeah, here's the greatest element, so this is starting at 0. Is this guy greater than 0? Yes. Wait, hold. No. We go through the whole thing. So is this one greater? Okay, now we set this guy. No, is this guy greater than this one? No. Is this guy greater? Yes. Yes. No. Yes. So now this is the final index. We have found the index, and now we swap array I with array final index, and then we start here. And then, oh, we find 9. Swap. Oh, we find 9 again. Swap. Find 9 again. Swap. Find 9 again. Swap. Find 9 again. Swap. Find 6, 8. Swap, etc. 6 swap. 4 swap. 2 swap. 2 swap. 2 swap. Or 5, 6, 5, 3, 2, 2, 2. 6, 5, 3, 2, 2, 2. Alright, what am I doing? Oh, it takes 2. A T reference A and a T reference B. And it creates a TC for B, or for A. A is now B. B is now C. Okay. Oh, here we go. I was like, wait, what? Hold. What the fuck is happening here? Oh, what the fuck? Why is it skipping down so far? I'm like, why does it look sorted, but short? Boom, unsorted, and then post sort. 3, boom, 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 boom. Easy peasy. Like, bro, what the fuck is happening? Twist down, double sort, and then some other stuff. Okay. Okay. I'll do bubble sort next.